Okay, so let's talk about even and odd functions and how their graphs behave. So even function. Function f of x equals y is called even if f of negative x is equals to f of x for every x in the domain. So that means a function gives the same output whether you plug a negative x or x. So as a result, the graph of an even function is symmetric with respect to the y-axis. So it is the mirror image on both sides of the y-axis. So a function y equals f of x is called odd if f of negative x is equals to negative f of x for every x in the domain. So this means a function gives opposite output if you switch the sign of x. So the graph of an odd function is symmetric with respect to the origin. So that means if you rotate the graph by 180 degrees around the origin, it looks the same. So to summarize, even functions, they are symmetric about y-axis, and odd functions, they are symmetric about the origin. And for even functions, all the even functions will satisfy this expression and all the odd functions will satisfy this expression. So now let's see some examples. Okay, so let's consider the three functions: x to the power 2, x to the power 4, x to the power c. Okay, all these three functions have the even exponent. So let's see what does that tells us. So for each function, if you check, for all these three functions, it satisfies that f of negative x is equals to f of x. So here I have shown all the calculations, so you can go through them. So for every function, we can prove that f of x is equals to f of negative x, which means all these three functions are even functions. So what does this mean graphically? So this means the graphs are symmetric about the y-axis. So if you fold all these three functions, the graphs about along the y-axis, both sides will match perfectly. So the even powered functions are look like U-shaped curves and they all open upward centered at the origin. So whenever the power function is even, the function will even too. The graph will reflect the symmetry. Next example. Next we have a trigonometric function y equals cosine x. So we want to determine whether this function even, odd or neither. So to check that, to check whether it's even, so we can take a look at f of negative x. So f of negative x is cosine negative x. So cosine negative x is equals to cosine x. The cosine x is f of x, which means for this function we can prove that f of negative x is equals to f of x, which means this is an even function. And you can confirm this by sketching this function. So if you sketch it, it will have a short shape like this. And again, so this is symmetric about y-axis. So it has the mirror symmetry across the y-axis. So the wave pattern repeats on the both sides in exactly the same way. So this makes cosine is one of the most known example for even trigonometric function. Okay, so next we have absolute value function f of x equals absolute value of x. So we want to determine whether it is even, odd or neither. To check whether it's even, we will use the definition. So let's start with f of negative x. So f of x is absolute value of x. So in order to get f of negative x, you have to replace x by negative x. So absolute value of negative x is always you have to get the positive value. So it's going to be x. So this x, you can write this as absolute x. So this is equals f of x. So yes, here f of negative x is equals to f of x. So that means f of absolute value of x is an even function. So if you graph f of x, the absolute value of f of x, absolute value of x is a V-shaped graph. So it is symmetric with respect to the y-axis. The left and the right sides of the graphs are mirror images. So anytime you see absolute value, you are working with an even function. Okay, next let's talk about x to the power 3, a cubic function. So here also we want to determine whether it's even, odd, or neither. So to check the oddness, we can use the definition again. So the definition, let's look at f of negative x, and let's try to simplify this. So f of x is equals to x to the power 3. So instead of x, I'm gonna put a negative x to the power 3. Now let's try to simplify this. So this means you have to multiply negative x 3 times by itself. So negative multiplied by a negative, a positive multiplied by a negative, you will get a negative value. So it's going to be negative x to the power 3. So here you can rewrite this as negative f of x. So here you can see f of negative x is equals to negative f of x. So this means f of x is an odd function. So graphically, this is what it means. So this is what we have as x to the power 3. So f of x is symmetric about the origin. So that means if you rotate this graph around the origin by 180 degrees, it looks exactly the same. So this is a key characteristics of an odd function, and x3 is a classic example for an odd function. Okay, the final example for an odd function, we have f of x equals 1 over x, a classic rational function. Okay, so we want to determine whether it's even, odd, or neither. To check that, let's use the definition. Let's start with f of x equals negative x. So this is going to replace x by negative x. So this is, we can rewrite this as negative multiplied by 1 over x. So this is negative f of x. So here for this example, f of negative x is equals to negative f of x, which means this is odd function. So graphically, this is what it means. So the graph of 1 over x is made up by two curves, one in the first quadrant and the other one is in the third quadrant, something like this. And the curve is symmetric with respect to the origin. So if you rotate the graph by 180 degrees around the origin, it looks exactly the same. So the key trait for odd function is this.